Hi everyone, welcome back to our channel. Today we are going to learn how to perform MATLAB simulation to verify reciprocity theorem. So this is the network what we need to develop. So here we are going to have for reciprocity theorem to validate only a single source should be there, and here we are having a T type of network, and we are finding the current in this 1000 ohm resistance, and the current is 8.752. So now V by I we had got for 3.4 kilo ohms resistor. Now as a verification of reciprocity, we are exciting the at output port, and we are finding the current at input port. Then also you can see here the resistance is 3428 ohms, and here the resistance is also 3428 ohms. That's how we can say that reciprocity theorem is validated. Let's try to do the same simulation using MATLAB now. So in order to do the MATLAB, so first open the MATLAB window. So this is the default MATLAB window, and click on the Simulink. Okay, then a file will be and Simulink model will be open, and here you can directly click on blank model. Okay, and blank model will be open. Then to do this very clearly and transparently, first minimize the MATLAB original window and drag it to the right hand side, and what we need to develop you keep it in the left hand side. Okay, then you can understand what are the key components we need to inject. So this is what we need to actually develop. Okay, so now we have to develop all those components in this new block. Okay, so to add all these elements, so first you have to click on the Simulink library browser, and here in the Simulink library browser, so first scroll it down and identify where is the Simscape. Click on the Simscape. In Simscape you go to electrical subsystem. In electrical subsystem go to specialized subsystem. In specialized subsystem go to fundamental blocks. Here you will be having all the blocks. Okay, so keep it aside. So identify what are the branches you require: voltage source, voltmeter, as well as ammeter and three resistance. Okay, so this is what we require. Okay, so now come to empty and see that we require all those elements. Okay, so we require an voltage source. Keep the drag the voltage source, and in order to run all this we require an power graphical user interface. Keep this power GUI here in this block, and then the next what we require is sources already kept elements. So in elements we require take the series RLC branch, and in series RLC branch after completing it, let us try to have the next element which is nothing but the measurement elements, which are nothing but voltmeter, and next one is nothing but here you can see here voltmeter and ammeter and branches and scopes. Okay, so voltmeter is completed. Next one we require ammeter and voltmeter. Now let us try to connect it. Okay, so you can minimize this library and open what actually we have to execute. Okay, so this is what we need to execute. So first double click on this series RLC branch and write down the type as R. Click on apply button and OK button, and you see this resistance value is 820 ohm. Okay, so here you can write down it as 820 ohm. Okay, click on apply as well as OK. Similarly, you make it as a T network. So copy this branch, Control C, Control V, and again Control V, and click on this branch and use the Control R button. It will rotate. So now the branch resistance value is 820. So we have defined it, and click on here also. So write down it as the value of this resistor is 820 ohms, and the next value is 510. This shunt branch is 510. So here write down it as 510 ohms and click on apply and OK. So the theoretical calculations for this is already available in our channel. You can check out there. And next series branch is 1000 ohm. So double click here and enter this value as a 1000 ohm and click on apply and OK button. Okay, so increase this and connect it in series. Just connect from positive to the resistor, and from here to here, and we require an output current at this branch. So take this ammeter and connect here. So just rotate it as control R. So connect the output of the resistance to positive and negative of this resistance to this closed path, and the negative of the voltage source to this closed path. So therefore we constructed this and we need to see the outputs. So connect. So what is the source is 30 volts. So double click on it and give the magnitude as 30 and click on apply and OK button and connect this to positive and connect this element to negative, and let's try to see the outputs. In order to see the output, let's try to go to the library browser, and here you can scroll it up, and here you can see here the commonly used blocks. So here you require sync to see the output. Click on the sync and drag the display into our untitled. Okay, so now the display is available here. So here you can connect one display here and just copy the display and paste it here also. Okay, now this is of you can here you can see here 30 825 and all the things we have been defined. So if you want to design it more clear, just drag it out, then you can find the things better. So just once run it. Okay, so and we need to find out the ratio of V by I. Just first try identify whether you're getting uh, current. Okay, so when you run it, you can see here we are getting 0 point which is nothing but current in amperes. Let's try to convert this into milliamperes. In order to do it, go to the browser, come to commonly used block, take out the grain and keep it in the untitled, and it's all amps, but let's try to convert into milliamps where you can understand it better. Okay, so let's try to inject here and double click on the gain and define this value as 1000 and click on apply and OK button. Connect this to output of the ammeter and connect with this to here and just run it. You can see here the current is in milliampere. Okay, so which is nothing but output current in milliamperes. So this is the first task is completed. So now we need to find out the voltage to the current. Okay, input voltage is nothing but excitation to the response. So in order to do it, just once again click on the browser. So here you can see here math operations. Okay, so in this math operation you can select divide. So move it to our untitled. So we need to find out excitation is how much voltage. So this is nothing but excitation to the response is here. So this is the response and we want to see the output. This is nothing but the resistance of the network. So this is R of the network. So just connect the output to the input of the scope. Just run it. Here you can see here the resistance of the resistance offered by this T network. So this is the total resistance offered by the T network. This is 3428 ohms. Now rather than giving the input at this port, now let's try to give the output at voltage at output port. Okay. So in order to perform it again, let us try to copy all these blocks again. So just make it maximized and copy this element and paste here and copy this shunt branch and place it down. So copy control C, control V. This is control C, control V. This is control C, control V, and you have to give the voltage at this side and ammeter at opposite direction. So control C, control V. So here we are going to excite the output port. Therefore copy this voltage source and give the excitation this side. Connect positive to positive and to this resistor and to this resistor, and from this resistor to ammeter positive and the negative of the ammeter to the resistance and try to close it. Okay, so if you want to define the element values, you can define. This is 820. This is a 510. So here you can write down it as a 510 ohms, and this value is 1000 ohm. So here you can write down it as 1000 ohms. Okay. The same here. Also here are going to have same the elements. So here we are giving the excitation. So connect the voltmeter. And now in order to measure the voltmeter, you require one voltmeter. Copy the voltmeter and paste the voltmeter and connect the positive to positive and negative to negative. And let's try to see the output. So this is nothing but the voltage what we are exciting. And in order to see the current also, let's try to connect an Control C, Control V, and the output current here also will keep one ammeter. So connect to the ammeter. So if you want more space, just move the ammeter to side. So now the current will be in terms of ammeter, and again we require to find out the voltage to the current. So copy this block, write down it as here, and paste it here, and we require the ratio of voltage excitation to the response. So voltage here you are going to have to hear the voltage is nothing but 30, and excitation is nothing but the current, and here you have to see the output of the network. Okay, this is the output of the network, and just connect it. And at the bottom you can write down resistance of the network. These two should be there. Just run it. You can see here input voltage I applied 30, and current is of same 8.752 amps. Here also 8.752 amps, and we are finding the ratio of excitation is voltage, response is nothing but current. You have got the same resistance value. Here you can see here the resistance of this T network. The resistance of this T network is 3428 ohms. Here also it is 3428 ohms. Hope you are able to understand. This is called the concept of a reciprocity theorem. So the reciprocity theorem concept is, so if this is valid only when we have single source. If it is an single source network, then we have to apply the voltage and we have to find the current in that branch, and we have to find the resistance. So you have to find the ratio of excitation to the response, then automatically the resistance will be same. This is how to validate the reciprocity theorem. So if you feel my explanation is good, please like the video, share the video with your friends, and if you have any doubts, let me know in the comment section. And if you're watching my channel for the first time, subscribe to my channel with the name kvthulasi. Kindly encourage these sort of free channels for the development of students and faculty. Yours obediently, Ram.